So here, see the message. What they have given is 1 0 0 1 1 1 0 1 1 1 0 0. So they are saying we want to generate 4-bit CRC. For generating the 4-bit CRC, first we will add 4 zeros. Correct?
Yes.
Initially, we will start with this stage. So we have to tell me.
Sir, like, sir, that polynomial is like 4 bits, no, sir? 4. Okay. And understood.
Yeah, it's not based on polynomial actually, to be frankly speaking. But see, even if they give whatever the polynomial, so as soon as they say that like 4-bit CRC we have to generate, just append that many bits of data. Like
Okay, sir.
Data plus CRC.
Yes.
So the polynomial what they have given is x to the power 4, right? So that is 4th bit is 1, x to the power 3 is 0, so next is actually 0, x to the power 2 is 1, and finally last one is 1, right? So this is the one which you have to use for division, right? 1 0
yes.
1 1. So
yes, sir.
now we have to start the long division. So how to start long division? First it is like 1, right? So when I take 1, it is 1 0 0 1, right? So everything will become 0, and then actually first if I bring 1, it is not possible to divide. Put 0 again, one more 1 I will bring it down, right?
Yes.
Then I'll put it 0 again, it is not possible. 0 0. Then finally I'll bring this 1 and it is 0. Then again 1 will become 1 0 1 1, right? So it will become
yes.
1, here also 1 0, correct?
Yes, sir.
So then finally bring this one, and again here it is 1 to become 1 0 1 1, so 0 1 1 0. Bring other 0 here, again 1, it will become 1 0 1 1, so this will become 1 1 1. We brought this 0 down, and this is 0 1, then it will become again 1 0 1 1, so 1 0 1. We brought this 0, now again bring this 0 1, it will become 1 0 1 1, then this will become 1, just 1, right?
Yes.
This will become 1. So how many 3 zeros we brought it down? So last 3 zeros are pending, 4 zeros are pending, right? So actually put 4 zeros up and bring 4 zeros down, correct? So
yes, sir.
If I do this, actually finally again like then 1 I have to give, right? So 1 0 1 1. No, actually as soon as I okay, yeah, we will do this. So it is 0 0 1 1. So this is the final one which I have to append.
Yes, sir.
Hope this is clear.
Yes, sir.
Okay, so this is the CRC what you will append. The same way this
Yes.
also, but here message they haven't given, so instead of that they have given in the polynomial way. So it will become 1, 5th bit is 1, 4th bit is 1, 3rd bit is 0, 2nd bit is 0, 1st bit is 1, 0th bit is 0. This is the message. And division
Yes.
divisor is actually 1 1 1 1101, right? And basically they are saying 3-bit CRC. So you have to do, you have to append 3 zeros here.
3 zeros.
And you have to divide 1,
Yes.
1, 0. Hope this you can handle, right?
Yes, sir. So like one more is there, sir. I'll send you the photo.
Sure.
This one. So can you explain this?
This one, right? So let us look
Yes,
at
sir.
some transmission scenario. Assume that sender sends data 1011. So he is sending 1011. So the code word created from this data word is 1011. He is appending one more one. Correct?
Yes, sir. Yes, sir.
So if no error occurred and we are receiving same thing, correct? At the receiver end.
Yes, sir.
Right? And
Yes, sir.
He's saying the syndrome is 0. In the sense, actually, when I compare this, right? So basically, this is done based on XORing, right? 101, 110, then this actually 110 and 1011, right? So here at the receiver end, if I XOR everything, the resulting is 0. So that means actually no error, right?
No error.
So
Yes,
first
sir.
case is actually no error. So if one single bit error is created, in the sense if this 1 became 0 now, right? Now if I XOR, this will become 1. So whenever I see this XOR result is 1, that means syndrome is 1, means actually I have an error, correct?
Yes, sir. See, sir, A1 means last bit, sir.
Which one?
Like, sir, like 1011. A1 means?
Where is A1?
Yes, sir.
A1 means,
One
no,
single.
no. A1 means, actually he is seeing, see here, it is A3, A2, A1 in that way, right? If you see 11101, right? So he changed this bit, right? This bit actually. Okay. So one bit single changes A1. No, actually, as per bit representation, A0, A1, A2, it has to be. I think he's mentioning whole word as A1. Okay, because like bitwise, if you consider anywhere, like, so this side or this side, this is A0, A1, A2, A3, A4. So he's referring one bit error changes A1. This entire thing it will.
Yes, sir.
Okay.
Yes, sir.
Just a second. Okay. So third scenario, one single bit error changes R0, the received code word basically. It is 10110. I mean, like, again, if the syndrome is 1, no data word is created. I mean, whenever there is a error, right? So we are getting the XOR result as 1, so the data word will not be created.
Yes.
Hope you got it, right?
Yes, sir. Yes.
Okay. So next one, an error changes R0 and the second error changes A3. So I mean, see, actually speaking, so the representation of bits are A0 plus A1 plus A2 plus A3 this way, right?
Yes, sir.
Yes. So he's saying the received code word. So here overall, if I mention this 10111, okay. So now here A0, A1, A2, A3, A4, correct? A4. He's saying fourth case, an error changed R0, okay, and the second error changes A3, okay. So he's saying this A3. So actually, this is treated as R0, right? Our syndrome bit, actually, XOR bit, right?
Syndrome bit.
So
Yes, sir.
correct. So he's saying error changes R0. So here instead of 1, 0, 1, 1, and both are changed actually. This became like 0, 0, correct?
Yes, sir.
The received code word is basically he's saying A3. He's saying A3 and okay. So he is considering ulta actually. So he started from A3, A2, A1, A0. So he's saying error changed this 1. Instead of 1, it became 0. And then again 0, 1, 1 as it is. R3 is last one. This got changed. Correct?
Yes. Yes, sir.
So now the
Yes, sir.
syndrome is 0. The data word actually is now 0011. Correct?
And yes, sir.
Yeah. So this syndrome is 0. I mean, in the sense, sorry, it also it became 0.
Yes, sir.
Now, actually, as per this, like whenever I XOR all these bits, it is 0, and this also 0, but error occurred. So even though it error occurred, but still the data word is created. It is treating that syndrome and this XOR is matching, right? So that's why data word is
Yes.
created, but it is wrongly created.
Yes, sir.
Okay. So
Yes.
that's where actually, if you remember, when I said the CRC check only works when there is an odd number of errors. You can see simple parity check code can only detect an odd number of errors. That's where like this exercise they have done. So just to show that like whenever there is an odd number of bits are erroneous, then only we will be able to detect the error.
Yes, sir.
Okay.
Sir, one more thing, sir. Like yesterday, like day before yesterday, like you thought that email thing so no, sir, in 5th unit. Can you explain that the 4 scenarios are there, sir? Can you explain the scenarios, sir? Once.
Okay, sure. This scenarios, which one?
No, not that, sir. Scenarios, this scenario.
Okay. Okay. So here, this is actually SMTP system. SMTP system we saw, right? So basically, it is like a system which handles mail exchanges, right?
Yes,
So
sir.
in the first scenario, the sender and receiver of an email are users of the same system. In the sense, like for instance, like let me consider Gmail. We consider both are in the same system, obviously, right? And they
Yes,
are
sir.
directly connected to the share system. And if I send through gmail.com to another gmail.com, they both will be in same actually, right? Alias will be same. So the administrator has created one mailbox for each user where received messages are stored. A mailbox is a part of local hard drive. It's basically storing in some storage, right? I mean, like now it is like we are not pushing into some other storage. Mail to Gmail is within the same storage. Only the owner of the mailbox has access to it. So when Alice, a user, need to send a message to Bob, another user. So Alice runs a user agent program. I mean, like how to send the mail. We will run the program for them and prepare the message and store it in the Bob's mailbox. Okay.
Yes.
So here we are just storing in his mailbox using authorized, administrative password, right? But it is not sending somewhere. I mean, it is like just storing it. So this first application, okay? In the sense like we are not in the different system. But now,
Yes.
second scenario where it is in the different server. For instance, like you are in Yahoo and another user is in Gmail. So then what it has to do, like it will through message transfer agent. So it will send from this storage to another message through that MTA server, right, of the other client system. So it will go and sit in that. So here through internet, it will pass from another storage. So it is not within the same storage, right? It has to pass and go to the another storage. This is the second scenario.
Yes, sir.
It is like you can think like Google to Google, Gmail to Gmail. This is Gmail to other, like yeah. So previously I was storing in the same, but in this location I'm storing. I'm not sending anywhere because both are in the same system. Now Yahoo may be in the different server, Gmail may be in the different server. So in that scenario, we have to send it. Correct?
Yes, sir.
Okay. Third scenario, the third scenario. Yeah, so it is like you might see in that like local one mail transfer systems you will install, right? A mailing client like so even though it's Gmail, so from Outlook or like from Mozilla Firefox you will get some client. So that you have installed, and here he is directly accessing to the browser or something like that. So this is one scenario. So from mail client, right, it will fetch through message transfer agent. Have you seen
Yes.
like installing not accessing the browser and also you will install some messaging client, message transfer agent. So and directly from the server it will fetch, and other side you will directly read from the browser. So this is another scenario.
Yes, sir.
Third scenario, both are in client, so it will fetch from the message transfer agent.
Sir. Yes, sir.
Okay.
Yes.
You have to think. I mean, like in when we study this data communication, right? You have to think in the real time scenario what you use every day.
Yes.
Be easy to correlate that.
Yes, sir. Okay.
Any other things?
One second. So this problem. Sir, I've sent you the problems.
Okay. So two hosts are in CSMA network and as data transfer capacity of 1 gigabits per second. The data rate they have given as 1 gigabits per second. So the frame length is 6 to 1000 bits. Propagation speed is 2 into 10 power 8. So what is the distance between? So frame length they have given as 1000 bits. So 1000 bits. So the time required to send one frame basically will become 1000 bits by data speed. It is actually 1 gigabits per second. Correct? So
Yes, sir.
how much it is actually? One microsecond, correct? 10 power minus 6 it will come.
Yes.
Right?
Yes.
So in CSMA with CD, always actually we send the data and we receive the acknowledgement, right? It is like two-way, correct?
Yes, sir. Yes.
So in two-way, it will become actually 2 microseconds. Total time of propagation.
Yes.
Round trip
Yes, sir.
time. Right?
Yes, sir.
So basically to find the distance, what is the formula? Propagation speed into the delay, that is like whatever we calculated, delay divided by 2. Correct?
Yes. Yes, sir.
Right?
Yes, sir.
So how much it is?
So delay is
it's usually twice the distance. Basically, see, delay is propagation time into basically distance is propagation speed into delay, right? Propagation speed into delay. Okay.
yes, sir.
But why it is 2 is like now, see, distance equals to propagation speed into delay. But now distance is twice the distance, right? That's where like it is like we are doing half of that. Okay. So
Yes.
now it is actually total delay what we calculate. Both the way we calculate. Okay? That's why it's a twice the distance. It has to go and get the acknowledgement. Twice the distance equals to propagation speed into round trip delay. Or else other way is propagation speed into delay equals to just a distance. But when we calculate that propagation speed, right, that is like we have to consider the one way delay only, not both way. Okay.
Yes. Yes, sir.
Propagation speed into delay. Okay, delay we have considered twice. So propagation speed they have given, right? 2 into 10 power 8 into delay 2 micro divided by 2. How much it is?
Yes. 2 into 10 to the power of 2, sir.
200 meters.
Yes.
So this Ethernet, I think, do we have Ethernet in your syllabus? I think we don't have, but is it there?
No, no, sir.
Okay, but actually, still, I mean, generally efficiency, how we calculate is the useful data transmission time, useful data TX time, divided by total time into 100. Okay. So here, basically, see, the data will be transmitted in Ethernet, and again it will be sent back in the acknowledgement, and again with the acknowledgement it will say that like whether he received or not. So actual transmission time is just 1 microsecond. Okay, but here we have 3-way, right? So it is 3 microseconds. So efficiency, it will come around 33% here in the Ethernet.
Yes, sir.
Okay.
Yes.
Okay. Anything else?
No, sir. That's it.
Okay. Fine then. All the best. Do well in tomorrow's exam.
Thank you, sir.
Okay. Thank you.